Hi, this is Nancy Mansell coming to you from CNN Behind the Glass. Now let's look at solving systems of equations by elimination. The elimination method works best when both equations are in standard form. Let's have a look at this problem. Notice that both are in standard form. Some books call the elimination method the addition method, and here's why. I'm going to add these equations. 2x plus 4x is 6x. 3x minus 3y cancel each other out. And negative 6 plus 6 is 0. Let's just divide by 6, and I have x equals 0. Okay. So I have my x. Now I need my y. Plug the 0 back into either equation. 2 times 0 plus 3y equals negative 6. And we'll divide both sides by 3. And y is negative 2. Okay, that makes my solution 0, negative 2. We can check it and make sure it's right. Let's go ahead and do that. So 2 times 0 plus 3 times negative 2 is negative 6. 0 minus 6 is negative 6. Negative 6 equals negative 6. Checks in the first one. Let's try it in the second one. 4 times 0 minus 3 times negative 2 is 6. Negative times negative is positive. 6 equals 6. Yep, checks in the second one as well. So I know that that's my solution. Okay, so why was that so easy? That was incredibly easy, wasn't it? The reason that was so easy is because, look, the coefficients of y were exact opposites of each other, and they canceled each other out. That's what we mean when we say elimination. We're trying to eliminate one of the variables. So will every problem be that easy? You know better than that. Let's look at the next problem. Look at the coefficients of x. Are they opposites? Nope. How about the coefficients of y's? Are they opposites? They are not opposites either. So what we have to do is we have to multiply either one, or in this case, both equations by something that will create opposites, either in the coefficients of x or the coefficients of y. One doesn't look any easier than the other to me, so what if we multiplied the first equation by 3 and the second equation by 2? Do you see where we're going here? 3 times negative 2 is going to give me negative 6y, and 2 times positive 3y is going to give me positive 6y, and the y's are going to be gone. Okay, so let's do it. Let's distribute. 3 times 15 times 5x is 15x. 3 times negative 2y is negative 6y, and 3 times 4 is 12. Good. Now the second equation. 2 times 2 is 4x. 2 times 3y is 6y. See how that worked? Yeah. And 2 times 13 is 26. Now we're ready to add the equations. Okay. 15x plus 4x is 19x. The y's cancel, equals 38. Okay. Let's divide both sides by 19, and x equals 2. Are we done? Nope. You know that a system of equations, these lines cross. You have to name where they cross. 2's not enough. I'm going to need to find the y that goes with it. So let's substitute a 2 into either equation. It doesn't matter which. Let's pick the first one. 5 times 2 minus 2y equals 4. So what we're doing now is we're solving for the y that goes right here. 10 minus 2y equals 4. Let's subtract 10 from both sides, and we'll have negative 2y equals negative 6. And finally, let's divide by negative 2. Looks like y equals 3. Okay, let's go ahead and check this one and make sure that it's correct. Going back to our original equation, we're plugging in the 2 for x, the 3 for y, to both equations, and see if we get true statements. So 5 times x is 2, minus 2 times y is 3 equals 4. It gives me 10 minus 6 is 4. 4 equals 4. That is true. So the first one checks. Now let's plug our stuff into the second equation and see if that one checks as well. 2 times x is 2 plus 3 times y is 3 equals 13. 4 plus 9 equals 13. 13 equals 13. Yes, it does. It checks. This is your solution. Good job. See you soon.